Okay. All right, so here we go. Evaluate the logarithm. Show work as if you had no calculator. So some of you were like, wait, we have a calculator. I'm very aware that I'm not going to know whether you're really using your calculator on these problems or not. However, when it says as if you had no calculator, that means I don't want any decimal answers, because having a decimal answer is kind of a dead giveaway that you used your calculator, right? So my suggestion is take each one of these and go into exponent form. So in this one, there's no base listed. What does that mean about the base? The base is 10. What's the exponent? Equals. How do I get a result of 1 if my base, it doesn't matter what my base is, how do I get a result of 1? Just find a seed anyway. It means that the exponent has to be what? 0. So on the quiz we took the other day, remember how I said don't type in x equals or y equals? Just like here, don't type in that y equals, just type in 0 as your answer. Okay? So far so good? All right. Number 2, the most commonly missed answer that I get is 12. If I go to exponent form, I have 12 to the y equals 144. And people think, oh, that's 12 times 12, which is 144. Yes, however, that's an exponent. That's not just saying multiply by a number. That needs to know what the exponent is. So 12 to the what power equals 144? Well, 144 is 12 squared, so y has to actually equal 2. Questions there? Okay. Next one. What's my base? 1 over 27. What's my exponent? Y equals 9. So here's my question. Can 1 over 27 and 9, actually let me rephrase this question. Can, ignoring the fact that this is a fraction, right now the fact that I have a fraction and a nice number only tells me that I have a negative exponent, correct? So I have my negative there. Can 27 be written as a power of 9? No, it's 9 times 3, but it's not 9 to some power, right? Which means I need to write both 1 over 27 and 9 as a power of something else. And in this case, both of them can be written as powers of 3. So, 1 over 27, well, I know 27 is 3 to the third, but since it's a fraction, it would be 3 to the negative third. So I squish a negative sign in there. To the y power. Does that make sense? Equals 3 to the what? Second. Again, the reason why this exponent is negative is because it becomes a fraction. And 3 to the third is what gets you 27. So it's got to be negative 3 to get that fraction with the 27. So once you have matching bases, you can just set this equal to this. So negative 3y equals 2. Divide by negative 3. And what do I get? Negative 2/3. So y is equal to negative 2/3. Okay. Questions there? I think number 4 is similar to that one. What's my base? 128. What's my exponent? Equals 32. Okay. I don't think 32 I can raise to a power and get 128. Right? So, I need to rewrite these as powers of something else. Well, I know 32 is 2 to the 5th. What about 128? 2 to the 7th to the y. Now, when you're doing these, most of these are going to end up having a common base of 3 or of 2. We're not going to give you ones necessarily that have huge common bases. They should be fairly quick to pull out. Once I have those 2's in common, I set 7y equal to 5. Divide by 7, and what's my answer? 5/7. Why is it not negative 5/7? Because there's no fraction. I'm not going from a fraction to a nice number or a nice number to a fraction. If I'm going from nice number to nice number, or if I'm going fraction to fraction, and I'm not changing forms at all, there's no negative. Okay? Any questions there? Okay. Moving on. I have a nice number to a fraction. Do you see that? Which means this is going to be a negative. What's my base? 25 to the what power? Y equals 1 over 625. Okay? Is 25 squared 625? I'm curious. 25 squared. It is. So we both have powers of 25. If you don't recognize that, you could do powers of 5 if you wanted to also, and you'll get to the same answer. So 25 to the y is equal to 1 over 625. If 625 is 25 squared, what does that mean? My answer is negative 2. Because in order to get 1 over 625, this would be 25 to the negative second equals 25 to the y. Matching bases, y equals negative 2. And number 6 messed some people up, but number 6 is actually a hidden matchy-matchy problem. What's the base of ln? E. So, if E is the base and I have an E there, there was a matchy-matchy rule that said if those two match, your answer is just 4. So you could use the matchy-matchy rule and be done. If you don't see the matchy-matchy rule, you can go to exponent form. So if your base is E, that would be e to the y equals e to the 4th. And if your base is matched, then y has to equal 4. Either way. Okay? So this was a hidden matchy-matchy. Other ways you could see a hidden matchy-matchy would be something like this. Do you see the hidden matchy-matchy? You have a base of 10 and a number of 10. So the answer there would also just be 4. Okay, that's another way a hidden matchy-matchy could show up. So? Good answer. All right, now we get to graphs. We got 4 graphs. Now, most of you who have had me before know how I do the graphs on a test. Usually I'll have you type in this stuff on the computer, and on your work page I'll give you your graph to actually draw your graph on. Okay. First thing I like to do for my graphs, fill in the easy points. The range for every single one of these is all real numbers. Right? So at least that guarantees me 1 point on each of them. It's a good start. Yeah? All right. Next thing I'm going to do is I'm going to take a minute and I'm going to do my rearranging here because that's going to help me get the rest of the stuff, right? So I like moving the equals y over here just because I'm weird. What would I do first? Add 2 to both sides. So log x plus 9 equals y plus 2. What's my base? To the what power? Y plus 2 equals x plus 9. Subtract by 9. 10 to the y plus 2 minus 9 equals x. Now, when you're typing this in, it is incredibly important that you type what's in the exponent and what's not in the exponent not in the exponent. Right? So, let's see. Over here I would write 10 to the y plus 2 minus 9. Do I need the equals x? No, because there's already an x equals. Now on your group test, I didn't mark down if you wrote equals x. On the computer, it will mark it wrong, and I have to manually go override that. So it's easier for me if you don't write the equals x, but I can fix it if you do. So don't freak out about that. All right, so knowing that, what is my h value? negative 9. What is my k value? Negative 2. So negative 2 goes here. Yeah? Negative 3, negative 4, negative 1, and 0. And then h is my asymptote. And that's all the way down here. How do I write in my asymptote here? X equals what? Negative 9. There was one group that didn't put the x equals. You will get marked wrong for that every time. Because negative 2 is just a number. It's not, or negative 9 is just a number. It's not a line. Must be written in the equation. What will my domain be? X is greater than negative 9. Now, if x is greater than negative 9, that means my graph's over here. There were a couple groups that actually ended up, maybe not on this one, but one on the back side, with their graphs on the left side of the asymptote. None of these will end up on the left side of the asymptote. So if you're getting stuff on the left side of the asymptote, you're doing something wrong. Go back and check your work. Okay? So, let me plug in my equation. 10 to the parentheses. I'm going to start off with negative 4 plus 2, close my parentheses, minus 9. I get negative 8.99. I'm going to go back and change that negative 4 to a negative 3, negative 8.9. Now I change it to a negative 2, negative 8, negative 1, 1, and 0, 91. Is it reasonable to get 91 there? Yes, because we're dealing with a base of 10, and we talked about how bases of 10, or powers of 10, get big really fast. So, negative 8.99, negative 4, negative 8.9, negative 3, negative 8, negative 2, and then positive 1, negative 1 is over there. So we've got something that turns pretty quickly, like that. Any questions there? Let me tell you how I broke down the 8 points for that. There were 8 points for that question. It's the same on the back. I give you 1 point for your domain, 1 point for your range, 1 point for your asymptote, 1 point for your equation. 1 point for the asymptote drawn in correctly, not incorrectly. 1 point for the graph actually done correctly, and then 2 points for your XY chart. Okay, I do not give credit here simply because that point is taken care of right here. Okay, so that's how the 8 points got broken down. So, are those 5 points over here important? Because that's where you get 2 of your points from. Okay? All right, backside. Here we go. Let's see. First thing I'm going to do, I'm going to move that y. And then I'm going to subtract 3. So, log base 2 of x minus 1 equals y minus 3. And going to exponent form, I have a base of 2 to the what power? Y minus 3 equals x minus 1. Add your 1. 2 to the y minus 3 plus 1 equals x. And that's what I put over here. 2 to the y minus 3 plus 1. What is my h value? 1. What is my k value? 3. So my asymptote is at 1. Okay. And then my k value of 3 goes in the middle. 2, 1, 4, 5. What's my domain going to be? X is greater than 1, and my asymptote? X equals 1. So? All right, to the calculator. 2 to the y, which I'm going to plug in 1, minus 3 plus 1. 1.25. Now I go back and change the 1 to a 2. 1.5, change it to a 3, and a 4, and a 5. Alright, so 1.25, 1, 1.52, 2, 3, 3, 4, and then 5, 5? Yeah? So again, what's the biggest thing to remember when you're actually drawing in your graph? It absolutely cannot what? Cross your asymptote. I should not see any part of the graph on this side of your asymptote. Now, the little thing for the arrow, yeah, that can cross, but the actual curve itself cannot cross the asymptote. Okay? Ready for the next one? Here we go. All right, what do I do first? Add 2. So, I'm doing this on the wrong side, aren't I? Trying to mess you up, aren't I? How cruel could I be? Well, let's try and do it backwards. What's my base? 1/4. What's my exponent? Equals x. And if I write my equation or I type my equation in like that, it will be marked wrong. Why will it be marked wrong like that? You have a fraction. If you do not put parentheses, you are saying that exponent only applies to the top. It must be in parentheses if you have a fraction as your base. That's what tells you that the exponent goes to the whole fraction and not just the numerator. A lot of people lost a point on that on the quiz for not putting those parentheses, so don't lose that point tomorrow. Okay, so let's see, 1/4 parentheses to the y plus 2. Okay, what's my h value? 0. What's my k value? -2. So my h value of 0, right there. My asymptote is x equals 0, and my domain is x is greater than 0. And then I plug in my -2 over here, so -3, -4, -1, and 0, and it's calculator time. So 1/4 in parentheses in your calculator also, because otherwise it won't calculate it correct, to the -4 plus 2, also in parentheses, and I get 16. Now I change the -4 to a -3, to a -2, to a -1, and then finally to a 0. 0 point, I'm just going to say 0.6. I know a lot of them I only give 1 digit pass, but you don't want your x value to be 0 because that would be on the asymptote. So 16 -4 is off my graph. 4 -3, 1 -2, 0.25 -1, and 0.60, or 0.06 I should say. And that's what my graph should look like. Yeah? Questions there? Last one? All right. I'm going to move the equals y since I didn't on the last problem. What do I do first? Divide by -2. So the natural log of x is equal to y over -2. What do I do at this point? Go to exponent form. What's my base? E to the what power? Y over -2 equals x. So e to the y over -2. Now, that messed up some people because it made them think that their k value was something different than it was. What's my h value to start off with? H is 0. K is not -2. It's not +2. That's all one thing. It would be what would be added or subtracted from that. There is nothing, so k is also 0. So I'm going to have 0, -1, -2, +1, and +2 in my XY chart. My asymptote is going to be x equals 0, and my domain is going to be x is greater than 0. Okay, and just to be clear, your domain has to be greater than. If you write greater than or equal to, is wrong. Why? It can't be equal to the asymptote. It cannot touch that asymptote. All right, I think we're ready for the calculator. So, e to the -2 divided by 2. 0.36, I'm going to call that 0.4. Now I changed that -2 on top. Ooh, hang on, I did something wrong there. You see that? I did -2 divided by +2. I meant to do -2 divided by -2 because that's what the problem says. So it's 2.7, not 0.4. Okay, now change that to a -1, and I get 1.6. Now change it to a 0. I get 1, a 1, 0.6, and a 2, and there's that 0.36, which I'm going to call 0.4. So, 2.7 -2, 2.7 -2, 1.6 -1, 1, 0, 0.61, and 0.42. So this one's a much more gradual curve. It's not quite as dramatic of a curve as some of the other ones. But it will continue curving like that. Okay. Any questions? Given how quickly you guys were able to finish your group test and how quickly I was able to finish this, you should have absolutely no problem finishing your test during the class period tomorrow, even though it's a Friday and classes are a little shorter, right? You should still have plenty of time. However, you do need to be aware, especially first period here, because tardiness tends to be a problem with some people. If you are tardy, you do not get extra time at the end of the period, okay? The test is only open from the beginning of class to the end of class. So if you're tardy, you're only cutting into your own time. Okay, so make sure you get here on time. Any questions? All right, happy studying.